So welcome to this session. So now we go to see the next topic is Jacobian. Definition: if u and v are functions of the independent variable x and y, then the Jacobian of u and v with respect to x and y is denoted by dou of u comma v divided by dou of x comma y. So defined by determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. Similarly, Jacobian of u, v and w. So previous case we saw only two variables. Here we can saw the three variables. Similarly, we can extend up to n variables. So Jacobian of three variables u, v, w with respect to x, y, z are denoted by dou of u comma v comma w divided by dou of x comma y comma z, and defined by determinant of dou u by dou x, dou u by dou y, dou v by dou z. Now the second row, dou v by dou x, dou v by dou y, dou v by dou z. Now the last row, dou w by dou x, dou w by dou y and dou w by dou z. So property number 1. If u and v are functions of x and y, then dou of u comma v divided by dou of x comma y, so into dou of x comma y divided by dou of u comma v is equal to 1. So the proof of this, if u and v are functions of x and y, then u is equal to f of x comma y and v is equal to g of x comma y. Solve x and y we get, so x is equal to h of u comma v and y is equal to k of u comma v. Then so we will get this dou u by dou x into dou x by dou u plus dou u by dou y plus dou y by dou u is equal to dou u by dou u, since dou u by dou u is equal to 1. Similarly, we will get the remaining three differentiate equations. So now dou v by dou x into divided by dou x by dou y into dou of x comma y divided by dou of u comma v is equal to, so we can write in the form of determinant of this. So here we can interchange the row and column of the second determinant, so we will get this case. So now according to this previous cases we will get that is equal to determinant of 1001, just you take the determinant you will get 1. So now the property number 2, if u and v are functions of x and y, where x and y are functions of r and theta. So u and v is the functions of xy and xy is r and theta. So then dou of u comma v divided by dou of r comma theta is equal to dou of u comma v divided by dou of x comma y into dou of r comma y divided by dou of r comma theta. So here this is the proof. So dou of uv divided by dou of xy. So write in this determinant, write the determinant. Similarly, dou of x comma y divided by dou of r comma theta, write this case. So now we can interchange the row and column in the second determinant. So then we will get in this case. So now we have to write in the format of this. So this is nothing but dou of u comma v divided by dou of r comma theta. Next, property number 3. If functions u and v are said to be functionally independent, if each can be expressed in terms of other, so otherwise f of u comma v is 0. So if u and v are functionally independent of the variable x and y, then so dou of u comma v divided by dou of x comma y is 0. So if it is 0 means we will say functionally independent. So given u and v are said to be functionally independent, then f of u is equal to 0. So now f of u comma v is equal to 0. So I go to differentiating with respect to the f function f with respect to u and v, we will get this. So this is equal to 0. So therefore, so eliminating dou f by dou u and dou f by dou v, we will get this is 0. So problem number 1. So if x is equal to r cos theta, comma y is equal to r sin theta, so find dou of x comma y divided by dou of r comma theta. So they given that here x is equal to r cos theta, so you go differentiating with respect to r, we will get dou x by dou r is equal to cos theta. So and same x with respect to theta, dou x by dou theta is equal to minus r sin theta. Differentiation of cos theta is minus sin theta. Again y. For the y we go to differentiating with respect to r and theta. First you go to differentiating with respect to r. So dou y by dou r is equal to differentiation of r is 1. Therefore since we with respect to r means theta is a constant term, sin theta is a constant. Therefore differentiation of r is 1. So 1 into sin theta is sin theta. Again dou y by dou theta. So differentiating the y with respect to theta will get r cos theta. So now Jacobian dou of r x comma y divided by dou of r comma theta is equal to determinant of dou of x comma r. So dou x by dou r is nothing but cos theta. Dou x by dou theta is minus r sin theta. Dou y by dou r is sin theta. Dou y by dou theta is r cos theta. Now you take the determinant. So r cos theta into cos theta is r cos square theta. So formula minus. So minus r into sin theta is minus r sin square theta. Now we have to bring this r outside and minus the minus is plus. Therefore we know that one r square, sorry, cos square theta plus sin square theta is 1. Therefore Jacobian of dou of x comma y divided by dou of r comma theta is equal to r. Next example number 2. If x is equal to u into 1 plus v and y is equal to v into 1 plus u, find dou of x comma y divided by dou of u comma v. Solution given, what it is given, x is given. What is your x? X is equal to u into 1 plus u. You go to differentiating with respect to u, we will get 1 plus v. With respect to v means we will get u. So similarly differentiating y with respect to u and v. So now we can replace dou x by dou u is equal to 1 plus v. Dou x by dou v is equal to u. Dou y by dou u is equal to v. And dou y by dou v is equal to 1 plus u. So now you take the determinant. So then you have to simplify this. We will get Jacobian of dou of x comma y divided by dou of u comma v is equal to 1 plus u plus v. So next example number 3. If u is equal to y square divided by 2x and v is equal to x square plus y square divided by 2x, find dou of u comma v divided by dou of x comma y. So given that u is equal to y square divided by 2x, v is equal to x square plus y square divided by 2x, this is given. So differentiating with respect to x, we will get dou u by dou x is equal to minus y square divided by 2x square. So differentiating with respect to y, we will get y by x. Similarly differentiating v with respect to x and y, so then we can replace in the determinant. So dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. So now, so I keep the term second row as it is, second column as it is. In the first column I commonly bring the 1 by 2x square outside. If I bring the, since it is a determinant, we will commonly bring out the similar element in the particular independently in the column or row itself. Therefore in the first column I go to commonly bring out the 1 by 2x square outside, you will get this case. So now keep that first column as it is. Now I go to bring the y by x outside, we will get 1 1. So now, so this is case now. So now we have to multiple x square into x is x cube, therefore y divided by 2x cube. So now we will take the determinant and simplify it, we will get this case. So therefore minus y by 2x. Jacobian is equal to dou of u comma v divided by dou of x comma y is equal to minus y by 2x. So next example, example number 4. If u is equal to a cos hx cos y, b is equal to a sin hx sin y, show that dou of u comma v divided by dou of x comma y is equal to, so a square by 2, so cos h 2x minus cos 2y. So u and v are given, you go to differentiating the function u with respect to x and y, similarly v with respect to x and y. So now we have to apply the formulas. So all the known values we have replaced it. Now we have to take the take the determinant. So here you can simplify this. So we will get, after simplification we will get a solution. So next problem number 5. So x is equal to r cos theta and y is equal to r sin theta. So verify that dou of x comma y divided by dou of r comma theta into dou of r comma theta divided by dou of x comma y is equal to 1. Here x is equal to r cos theta, y is equal to r sin theta. So therefore square both the sides, will get x square is equal to r square cos square theta, y square is equal to r square sin square theta. So therefore x square plus y square is equal to, so sum of the squaring term, x square plus y square is equal to r square cos square theta plus r square sin square theta. Commonly bring out the r square outside, we get cos square theta plus sin square theta. So we know the result, cos square theta plus sin square theta is equal to 1. Therefore x square plus y square is equal to r square. So now r is nothing but square root of x square plus y square. So y by x is equal to, so already we know that one. So x is equal to r cos theta, y is equal to r sin theta. So divided this equation by this, therefore y by x is equal to tan theta. Therefore theta is nothing but tan inverse of y by x. Now we know that one, x, y, r, theta. Therefore, so x is equal to r cos theta, y is equal to r sin theta. So r is equal to square root of x square y square and theta is equal to tan inverse of y by x. These four results, the first two result is given in the problem itself. With the help of the first two results, we will get r and theta. So now we go to differentiating with respect to x with respect to r and theta, and y with respect to r and theta. Similarly r with respect to x and y. Similarly theta with respect to x and y. So you go to differentiating this with respect to x and y, r and theta. So now dou x by dou y, dou of x comma y divided by dou of r comma theta into dou of r comma theta divided by dou of x comma y. So this is the result. So from the given result we have replaced it. Just we have to simplify that, we will get dou of x comma y divided by dou of r comma theta into dou of r comma theta divided by dou of x comma y is equal to 1. So this is the desired result we want to prove. Therefore it's proved. Thank you.